Okay, so now we're doing converting rational exponents to radicals or radicals to rational exponents. So rational exponents, you're going to have your base, and it's going to be to some kind of power, let's say m over n. So your base is always going to be inside your root, and then the m over n, the m is always going to follow your base. So the m is going to be the power of this a. The n is always the index of your root. So the n is always the index here, so n. And that's how you convert it. Whether you're looking at the root, it's always going to go back to that power, or if you're looking to the power, it's going to convert to that root, okay? So when we look at number 1 here, we're asking to convert this to exponential form. The first thing I'm noticing is 2 things. I'm looking at my index right now, and it's invisible. I know that's a square root. I'm going to put a little 2 in for us. Okay, so now the number inside my square root, this 6x is all to the power of 3. So I know 6x is like my a here. So 6x all to the power of 3. And then the root is the denominator of that power. So I know it has to be over 2. And there you go. You've converted that to exponential form. Let's go the opposite direction now. So converting to radical form. So again, we know that this is our power, and we know 7 is the root or the index. So let's put our 7x inside our root. Notice that it's in parentheses, so we're going to keep it in parentheses. Its power is 5, and the root is 7. So that's how you convert. The other thing I want to talk about is solving rational equations. So you're going to see these 2 different ways. You might need to do some converting into a root, so like we did on number 2 here. This one was already nicely given to us as a radical. So whenever you're solving for a radical and your variable is trapped underneath the root, the first step you always want to do is you need to isolate this root, because otherwise the math isn't going to work for you. So isolate that first. So isolating means we get everything else surrounding it away first. So I'm going to add my 9 to both sides to start. So add 9, add 9. So now I have 1 plus 9, which is 10 on the left side. And I still have this root. So negative 10 plus m. From here, remember that we cancel roots by raising both sides to a power that matches the index of that root. So this is a square root. Its imaginary invisible index is a 2. So we're going to raise both sides to a 2. So 10 to the power of 2, 10 squared is 100. A power of 2 and a square root cancel each other, leaving negative 10 plus m. Last thing we're going to do is add 10 to both sides. So that gives us 110 equals m. And we're all done.